Good afternoon, everyone. So we are now on to part 2 of EE 4204. So are you all in the right class? Yes? Anyone here for some other class? Okay, so my name is Mehul Mohtani. My last name is Mohtani. So I'll be taking you through the second half of this module. Okay, and what I'm going to do first is, so this is the first time I'm seeing you, so I thought it's good for us to set some expectations, right? Both from what I expect as well as what you expect. Okay, so these sort of these administrative slides are a bit strange because I usually do it at the first lecture, but this is my first lecture with you. Okay, can everybody hear me? In the back there, the back seems very popular. Is there a seat for me back there? Can I join you guys? So I'm just curious, why does everybody like the back? You guys in the back, tell me. The gentleman with the white shirt. A full view. Can you come here? No. You can keep your stuff there. Just stand there for a second. Just sit here for 1 second and see if you don't get a full view. Try it next time. What? You prefer this, but I can't hear you. That's the problem, right? The problem is I have a microphone, you could all hear me. I cannot hear you guys. So this is a practical appeal. Okay? If you can somehow get over what's holding you back, let's try to sit a little bit in the front. Okay? Because as you're going to see, this is not going to be a one-way information dump. I'm not going to just talk to you and you sit back and absorb. You remember, those of you who've taken chemistry, there's something in chemistry called osmosis. Right? Osmosis is when chemicals permeate through membrane. Knowledge doesn't work like that. It cannot be I speak and by osmosis you will learn. So the practical constraint is that all you guys in the back, I cannot hear you, and I'm going to call on you, and I cannot hear you. So I may have to just walk up to you. So don't be shocked if I walk up the stairs, okay? So, but if possible, this class you guys didn't know, but if possible, let's try to sit in front. There's lots of seats in the front, okay? Oh no, my computer's going to restart. Snooze. Okay, so for those of you who've just walked in, my name is Mohtani. So Mohtani is my last name. This thing keeps cutting out. Hang on. So Mohtani is my last name, okay? I'm just clarifying in case it's a bit of there's any confusion. Okay, so some admin details. Here's some contact information for myself and the previous lecturer, Prof. Guruswamy. Here is the assessment structure. This is slightly different from what I uploaded I uploaded some notes to Luminous, but I had some discussion with Prof. Guruswamy, and so we made some slight adjustments. It's not major, just because as I wrote to you, I think all of you got my email, right? As I wrote to you, we're going to be doing things in class, these so-called lecture activities, and also there's the homework, and all of that combined, we want to give you credit for it. So there's the lecture activities, there's a 5% for that. You could also think of it as class participation, all right? And so all we did was we just equalized the three other assignments, CA1, CA2, CA3. Right, the lab and quizzes, so they're all equal. Okay, and then you have a final exam that's 50%. I'll say more about that at the end of the semester. Okay. Let's see. Okay, so what are we going to do in the second half of class? So obviously we're going to talk about computer networks. Right? But what topics in computer networks? So to understand what topics we're going to cover, can you tell me what you've covered already? Who can summarize what you have done in the first half of class? Any ideas? Yeah? What have you done in the first half of class? Yeah, this gentleman here. Yes. Sorry? Okay, that's fine. If you don't know, it's okay. I don't know is a very good place to be, right? Because there's only one way forward, which is to learn. So it's okay that you don't know. So how about other people? What? I just pick on you because you walked in. First half of class. Yeah, what was the topics? Can you summarize really quickly? Don't give me a half-hour lecture.
We just went through some of the protocols and how the layers work and
Okay. What was the okay, you talked about layers. So what was the major layer that you studied? Do you know? The gentleman in the gray shirt.
which layer was,
Yeah, which layer?
I think a bit of like the first part, like from physical to
Okay. I think you did layer 2. You might have talked about general things, but if you didn't know this is how you need to understand what you did. You see, learning is not about just learning equations and details. It's about taking a step back and seeing a structure and getting a meta view of what you did. What you did in the first half of class was layer 2. And what we're going to do in the second half of class is layer 3 and 4. You get it? Isn't that a good way to understand what you did in this class? We're not going to do layer 1. You didn't talk about physical layer. And we're not going to go above transport layer. Of course, we'll talk about it, right? We'll talk about the different layers. But in depth, you talked about layer. Do layer 3 and 4 in the second half. Okay, and we're going to talk about protocols, ideas, and so on that sit at all the layers. And of course, we'll also try to look at the entire communication problem as well. Okay, so that's it, right? So I'll say a little bit about protocols, layering, but the heart of what we're going to do is network and transport layer, and then I want to do some hands-on. Okay, so as I say, it's not going to be osmosis. We're going to talk. We're going to ask why, and we'll do some, let's say, dissection of networking data. Okay, some references here. I would say that the first book I've listed here, Kuros and Ross, is a very good book. If you want to invest in one book about computer networking, this is the one. Okay, it covers everything from physical layer all the way up to application layer, security, wireless, and everything. It's a good reference to have. All right, and there are many avenues by which the book can be acquired, and I will leave it at that. Okay, and then there's a whole bunch of other books that if you're interested in getting more information. I'm a fan of seeing things from many different points of view. Right, so I will share my point of view, right? But the book gives you a point of view. These other references give you a point of view, and I will share articles and some information that gives you things from slightly different points of view. And the whole point is for you to develop your own point of view. You get it? It's not about absorbing information. It's not about seeing what I say, listening to what I say, memorizing it, and then regurgitating it. That's not learning. You have to develop your own point of view. All right. So I guess you're in this class because some of you have to take it, right? Who's here because they have to take it? Yeah. Okay, most of you. Who's here because they're not required to take it, but it's of interest to them? Okay. And now you would think these are the only two sets of people, but there's actually a third set, which is who's here because you heard I was going to be teaching the module. And I'm such an awesome lecturer, right? So, okay, the first A in the class. No, just kidding. This is being webcast, right? So, I'm just kidding, obviously. Okay, so why in this class? I know you're all here for a wide range of reasons. The reason I put this up is that if there's something that you want to talk about that's not in the syllabus or that I'm not planning to, why don't you just bring it up? Just ask me. Say, hey, I heard about this. I give you the right to put me on the spot. Ask me about something you read or heard about, and I'll try to discuss it. If I don't know, I'll tell you no idea or I don't know, and I'll go find out, and then I'll share it with you. Share my thoughts with you, okay? So that's why I want to know why you're taking this class. So what do I expect? So I know we're only going to be seeing each other for like 7 weeks, it's the second half of the semester, but I still feel like I can tell you what I expect. So those of you in the webcast, hello. Please pay attention, and I hope what I'm about to tell you convinces you to come to class, because class is going to be quite awesome. Okay, we're going to do lots of fun things. So what do I expect? I expect you to make a sincere effort, right? You're here to learn, so no point in just sitting back and, not learning. Make an effort. I expect you to ask questions, right? This is where this point of me not being able to hear you comes into play. If I can't hear you, I can't answer your question. And I'm going to ask questions, so if I can't hear your answer, that causes disruption in the whole interaction. Okay, do the homework, right? I'm going to give you homework. Doing homework is not about getting the answers and parroting the answers, right? This gets to my theory of learning. Learning, so I will say this once, I won't say it again. Okay, learning is hard. Learning is confusing. Learning starts from confusion. In fact, the process of learning is being thoroughly confused and finding your way out of confusion. That's learning. Do you understand? If you're confused or if you don't know, that's why I say it's a good starting point. Okay, so I expect you to do the homework. I expect you to start with a clean sheet of paper. You see, I won't make any assumptions about you because I don't know you all. I hope to get to know you, but my past experience, this is how people treat homework. And, like if, let's say, people release the homework and the solutions along with it. In many of your classes, the lecturers release the homework, the tutorials as well as the solutions, right? At the same time. So, again, you can think about what you do, but what I've noticed people do is they'll print out the homework, they print out the solutions. Question 1, read the question. Great. Go to solutions. Solution 1, I understand. Question 2, solution 2, and so on. You've learned nothing. Okay? So don't do that. Right? Even after I release the solutions or whatever, start with a clean sheet of paper and say, what do I do? If you don't know what to do, come ask me. I will tell you what the first step is. Then you take the first step. And you see how far you get. When you get stuck again, you come see me. That me could be your classmates as well. You can ask your classmates for help. I'm okay with that. I'm okay if you work together. But don't copy this person's homework. Just tell them, hey, I got to this part. What do I do next? The good thing is it helps your classmate. Right? You all know that the best way to learn something is to teach it, right? So give your classmates an opportunity to learn by asking them to help you. Okay, not give you the answer. All right, so do the homework. And we're going to have lecture activities, as I said. So do those with sincerity. And then self-learning, read on your own. I'm going to give you some things to read. Go read newspapers, magazines, blogs about networking. Go Google what's happening in Wi-Fi. So does anyone know what's the latest thing in Wi-Fi? Sorry? Crack? Okay, you mean cracking passwords? Okay, wow, this is new to me. What's crack? No, that's cool. I don't know. You teach me something. What is that?
Remember the time that say FBI asked everyone to reboot the router?
Uh-huh.
It's because there's a vulnerability discovered by a white hat.
Okay, so that's really cool. So that's a vulnerability. So this is something I don't know about, right? So maybe next time we'll find some time you can share some more. Go find out some more. But what else? That's not what I was thinking of. What does anyone know what the next generation of Wi-Fi is? Yeah, it's Wi-Fi 6, right? Go Google it. Find out what's happening in Wi-Fi. The point is, right? You don't want to just like learn in isolation. Especially computer networking is part of the real world. There's things happening every day. So, go read. That's what I mean by self-learning. Read on your own. If you come across something you don't understand, quote unquote, clip out the article. These days, no one, we read online. So, clip it out, virtually and bring it up in class. And I'll try to see if I can say something about it. All right. How can you ask questions? So, of course, old school, raise your hands. You can send me an SMS. Let's see. I don't like Windows, but I'm forced to use it. Okay, here we go. I still remember what the things are. So here's my, oh no. Okay. Okay, there's my mobile. Okay, got it? Good. Okay. No taking. No, it's okay. Watch. Go. Remember it. Hey, he's taking a photo. Okay, it's okay. I'll let you take a photo. All right. No, I don't mind. So the new school way of, if you're really shy, you can just message me. Okay, even during class. All right. That's why I have my phone here in case somebody wants to message me. But you can message. But look, be responsible, right? Somebody groaned there. Does that mean you didn't get it? It's not. It's a secret, right? So the point is, be responsible. Okay. You can message me. You can ask me questions. The best way is probably WhatsApp. You can call me if you want, but be careful when you call me. Use your judgment. So I always tell students this. If you call me at like 3 a.m., I might be a little bit annoyed, but what I'm going to do is I'm going to call you back like every day at 3 a.m. for a couple of weeks to show you how it feels. So you will learn judgment. Okay? But anyway, the reason I give this to you is I don't want there to be any barrier in you getting your questions answered. Okay? But the best place, in my opinion, is come to class and ask me. Old school. You're here. Right? If there's a lot of value in talking to somebody face to face, because communication, as you know, there's some saying communication is like 90% nonverbal, right? So texting, all that stuff is just the content, but there's a 90% of it is missing, like looking at the other person, seeing their reaction. It's all missing, but we get that. So ask me questions, okay? So that's what I expect. So the way we're going to run the class, I think I've already alluded to it. We're going to have a two-way interaction. So critical thinking, so independent learning I already talked about, but critical thinking. Now, the word critical thinking gets thrown around a lot. But what does it actually mean? I think I'd be hard-pressed to get a real answer to that. I'll tell you what it means to me. What it means to me is that we ask why about everything. Okay? For example, there's a protocol. The first question should be, why did they do that? Why are they doing that? Okay? People think that studying computer networking is about facts, and it's not. I don't see it that way. I see it as understanding why, let's say, this network is designed this way. Right? The reason you want to do that is that when you build the next network, you want to know which decisions were required, why they were required, and which decisions were arbitrary. It turns out that the majority of decisions are arbitrary. Arbitrary meaning they could have easily been other choices and things would have still worked. Then you say, why this over that? Well, this over that because to make a protocol, you have to specify something. You have to be precise. So you have to make a decision. But sometimes it doesn't matter what the decision is. So I want you to walk away knowing what decisions are critical, what decisions are arbitrary. So that when you design the next network, you can make that same distinction. All right, what will you get out of it? Of course, you'll understand some concepts. You'll learn how to think about problems. So that's where the why comes in. Hopefully, you learn how to learn. I've already shown you a little bit about my view of learning and a good grade in this class. Right? So so I'm going to set a bar. If everybody steps above that bar, you all get a good grade. Okay? I will do that. All right? Yeah, this is a pretty large class, so bell curve kicks in, but it doesn't have to. If you all step up, make sure you all get a good grade. Okay? Like that's my promise to you. But your promise to me has to be to step up. If there are any questions, please ask, okay? Stick in and out. I wonder if I can switch. Is the AV people here? Okay. Yeah, because it's two mics. But I'm wondering if they're recording. Sorry. No, I'm wondering if they're recording off mic 1. Can I change to mic 4? I'm not sure. This place is falling apart. All right. Okay, so step up, good grade. Okay? I told you should go and learn on your own. So this is just a slide that talks about some resources. Okay? You probably know about all of these. The thing you probably never thought about was to talk to other professors. Right? Which is up there. Talk to other people. You can talk to other professors. I can get you in touch with people who work on networking problems, right? Or network-related problems, right? There's a lot of PhD students and master students who you could ask them. So why do you like networking? What kind of problems are you working on? Okay. All right, and then of course our digital library and so on. Okay, so on the left is what we're going to do, right? Link layer, transport layer, network layer. But the right is what we are not going to do. Right? So that's why one class cannot teach you everything. Right? One semester of networking is not going to teach you everything. But I want to teach you how to think about networking so that you can go learn whatever else you want to learn. Right? That's the aim. Okay, so any questions? I want to just move on to so I'm going to say some stuff about layering. But it'll be quick because you guys already have talked about layering, right? But I'll give you my own view. Okay, so any questions about administrative details, expectations, and so on? Okay, so just to remind you, I hope that when you come in the future, please keep in mind that it would be really great if we could be a bit more compact. So come to the front. Okay, just keep that in mind as you're making your seating decisions. Okay, I'm not going to force you all to come to the front, but it'd be really nice if we were here and we could talk to each other. Okay, so any questions? So everything clear so far? Okay, so I'm going to say something about this idea of layering. Okay, just some credit. So this credit holds true for all of my slides. I have a student, Vineet Srivatsawa. He did a master's with me on cross-layer design in networking, and some of the slides, some of the graphics are taken from his master's thesis. The other thing is Kuros and Ross are they're very kind in that along with their book, they provide a whole lot of graphics. And I've been very liberal with using and modifying their graphics, so I want to give them credit. So virtually all of the graphics you see are, so if you get the book, you will see the graphics in the book because they make those graphics available to lecturers. Okay? Okay, so yeah, we'll talk a little bit about what is layering, the OSI, the Open Systems Interconnect model, and we'll look inside the protocol stack a bit. So kind of an introduction, okay? So this picture shows you the architecture of modern networks. All right, you have devices at the edge, which are meant to be connected. So they're running applications that rely on interaction with other devices at the edge. So here, the devices at the edge are the PCs, laptops, phones, and so on. Okay, these devices connect through an access link to a core network. This access link can be wired, can be wireless, can be optical. Okay, so there's an access link, and then the core network consists of these. So the access is often provided by base stations or access points, okay, which are the kind of the red triangles here, and then those connect to the core network, which I'm representing by the blue routers, the blue disks. So these are the core routers in the internet, and so this forms a fully connected network, right? Sorry, it's a connected network, not a fully connected network. It's a connected network in the sense that there exists a path from any edge device to some other edge device. Okay, and there's going to be a set of rules, protocols that govern how these edge devices talk. These protocols are sort of embedded into these standards like GSM, Wi-Fi, and so on. Okay, and these standards are usually developed by international bodies. So for example, some of the Wi-Fi standards are developed by a body called IEEE and IETF, the Internet Engineering Task Force, is also responsible for many of these standards and protocols. Okay, so this is sort of a high-level view of modern networks. So I mentioned that the devices are interacting with each other, so they need a common language, which is a protocol. Okay, so a protocol is nothing but sort of this language. It defines the acceptable behavior. It defines how I react when I get a message and what messages I send when I want to initiate something. Okay, so for example, we have protocols in everyday life as well. Like if I meet you on the street, I can say hi. Are you going to say anything to me? Like if I say hi, you will respond, right? Most likely, unless you're very upset with me. Then you'll be like, you grumble and walk away. No, the sort of common behavioral pattern is to respond, right? Hi. I ask you, do you have the time? You say, yeah, the time is this, right? So that's a protocol. Of course, that's not explicit. There's no precise protocol, but you get the idea, right? Now, in computer networking, it's the same way, right? Your computer, which is, let's say, your laptop or your phone, makes a request to, this could be, for example, the YouTube server. It makes a request to YouTube for a video, and there's a sort of a back and forth, and eventually you get your video, right? So protocols are useful. They allow you to, use services and so on. So I'm sure if you think about it, you can think of lots of protocols, both human protocols as well as computer protocols, okay, network protocols. Okay, so the way I see it, what we are doing when we design a protocol or a set of protocols is we're solving a problem, right? So in computer networking, what's the problem that we are solving? Can anyone guess? What's the problem that we are solving?
Communication.
Yeah, who said that? Yeah. Okay, so that's correct, but okay, can you maybe add one or two more thoughts? Communication between
Between numerous devices.
yeah, exactly. So let's simplify. So that's spot on. Communication between a sender and a receiver. Okay? And an intended destination. Okay, so that's the problem. Communication between a sender and an intended destination. Later, we'll see that this problem is not unique to computer networks. But that is the problem that's being solved. And it turns out that that's a very hard problem. Extremely hard problem. And what do you do with hard problems? You, like for example, when you're going to be studying for the final exam for this class, right? I guarantee it's going to be damn hard. Right? So how are you going to prepare? Yeah? Study every chapter, but at the same time, you're going to like in parallel do one word from chapter 1, no, right? Yeah, you're going to break it up. Because, okay, first let me understand this topic. Then let me understand this topic. And so on. So I call this divide and conquer. Right? You're going to conquer. You're all going to do well. Right? You will conquer the subject. Don't worry. Okay? So protocol layering is the same way. It's the idea of a very big problem. You break it up into smaller problems. And those smaller problems you solve. And then you stitch together a solution to the big problem. All right? So when you're seeing layering, think about that. Think about the big problem that, tell me your name? Rushan. R-U-S-H-A-N. Rushan. What Rushan said, right? Communication, or my paraphrasing of it, communication between a sender and an intended destination, okay? So let's take the problem out of computer networking. And let's say that you want to just communicate with a friend. Okay, so let's say you have a friend, so one of my favorite places in the world is Hawaii. Okay, so I like to bring it into my examples. So I have a friend in Hawaii. Okay, and I want to talk to my friend. So what do you think is one way I can communicate with my friend? Suppose I want to say something to my friend. Can you think, how could I do it? Okay, can you think of suppose we're 100 years ago. 100 years ago or 200 years ago. Well, one thing I could do is maybe I could yell and hope that he hears me, he or she hears me. But Hawaii is quite far, right? It's middle of Pacific Ocean, right? So yeah, you would go there. 200 years ago there were no planes, but let's say I get on a ship and I go there, right? Or today, if I want to, I can go buy an airline ticket. I can get on a plane, go to Hawaii, and go see my friend and tell. Suppose that it's my girlfriend, and I want to tell her I love her. So I fly there, I go there, I love you, right? No, I mean that's what I call the brute force solution. Okay? Now, what's the layered solution? So I want to give you an example of layering, right? So the communication between don't know why this thing keeps cutting out. Hello? But it's really cutting in and out. So the main problem is not you guys. I can talk to you. I can speak loud enough, but we'll have to get IT to fix this. CIT. Okay. So the layered solution is not me going there. The layered solution is maybe sending a letter, right? So if you think about it, I mean, that's what we would do, right? Write a letter maybe, right? Okay, so let's not use the computer network because I want an example out of networking. Okay, so what's the layered solution in the real world, in the physical world? Well, I use the post office. So I write a letter, I'm going to address it, put a stamp on it, right? Write my letter, put it in the envelope. And what's my job? I need to get it to a post box. So I have to think, okay, I live in Clementi, where's the nearest post box? That's all I need. So I walk to the post box, I put it in the post box, and I wash my hands of it. What do I expect to happen? I expect that the postman will come, take it from the post box, bring it to the local exchange, the Clementi exchange. And that's all that guy has to do. He doesn't have to do anything else. So the first problem was me getting it to the post box. Second problem was the postman getting it from the post box to Clementi exchange. Then the postman washes his hands of it. The clerk at the exchange has to sort it. And they see, oh, it's meant for overseas. So put it into this pile, get it on a truck. That clerk can wash his or her hands of it, and so on. Then the truck driver has to get it from Clementi to Changi. And then it has to get onto a plane. But none of these people have to know how to fly a plane. The pilot knows how to fly the plane. Flies it to Hawaii and so on. So you see how the problem was broken up into smaller problems? Yeah, and that's layering. Okay? Now, this is kind of a silly little example, but I want to use it to teach you something else, or to help you realize something else. Let me ask you a question. Which solution is better? The one on the left, hand deliver, or the one on the right, use the post office? Which one is better? Louder. Okay, so what's your name? Spell it for me. Chun Hui said it depends. Okay, why does it depend?
Really depend on what you want. If you want convenience, then definitely post office. But sometimes it may get lost on the way.
Oh, yeah.
Then maybe hand delivery is like more reassuring.
Yeah. So this is exactly what I was getting at. It depends. So what Chun Hui said is right on. It depends. It depends on what is important to you, right? So if, for example, the example that Chun Hui gave, I hadn't thought of, which is, if you want convenience, then use the post office. But the post office is not 100% guarantee. If you want to have 100% guarantee, or close to it, go and hand deliver it yourself, right? The example I had in mind was cost versus time, right? If the time to get there is your concern, would you use the right or left? Would you use the left solution or the right solution? If, let's say, your girlfriend is going to be marrying someone else, and you have to stop, this is like a movie, right? You have to stop the wedding. You have to go tell her, I love you, before she gets married. Are you going to write her a letter? No, right? Because she's getting married tomorrow, let's say tomorrow night, and your letter's not going to get there in time, right? So if time is of essence, you go there. But let's say you're a poor university student, and it's just, there's no marriage involved, but you just want to tell somebody your affection for them. A handwritten letter might be nice, right? And the cost is much less. Right? So this is a very important point here. Okay? When I asked you which is better, that question was not a meaningful question. Because I didn't tell you what the metric to measure betterness was. Okay? So now I'm putting you all on notice. Okay? So if you get questions like which one is better, which one is optimal, which one is, the best solution, all those things have no meaning unless you are given a metric by which to measure that characteristic. Okay, and you putting your all on notice is I'm going to try to trick you. Okay, I'm going to ask you these kind of questions without telling you the metric, and if you answer it, you've kind of stumbled. Okay, the right question to ask is, well, if I say which is better, you say, well, it depends on what the metric is. So tell me the metric, and I'll tell you which one is better. Okay, yeah, like if you got to buy a new phone, and I give you two choices. Let's say the new Samsung. What does Samsung have a new phone? Galaxy Note 10 and iPhone 11. If I give you these two and I ask you which one is better, would you be able to tell me? I mean, I think it depends again, right? Depends. For some people, maybe the size is the important one. Some people, battery life. Maybe for some people, the apps that are available, right? One's Android, one's iOS, right? So it depends. It's not clear at all. The same thing in networking. A protocol or a system, there's no better. It depends on how you want to evaluate it. Okay? So anyway, from this slide, we learned about layering, an example out of networking, but we also learned about how to evaluate systems. Okay? Okay, so I think you all have seen this. This is what's called the OSI model. OSI stands for Open Systems Interconnect. It's a reference model for solving or for building a communication or a computer network protocol. I'm going to use communication and computer interchangeably. Okay, for building a network protocol. Okay, and what we want to do is so remember I told you what was the big problem? I want to communicate some information from a sender to an intended destination. Right? So let's see how this solves that problem. Okay? So now the assumption, the most general case is that the sender and receiver are not directly connected. Okay? So they are remote from each other, which means I need to have a series of intermediate nodes to carry my data. Okay? That's the most general case. Of course, if they were directly connected, part of this problem is solved. Okay? But let's assume they're remote, okay, and not directly connected, so there's a series of intermediate hops. So this reference stack has 7 layers, and each of those 7 layers does something. Okay? So can you tell me what these layers do? Like have you thought about this? Can you articulate in like one sentence what every layer does? Is anyone brave enough to try? Like, okay, let's start with the physical layer, which is layer 1. So what does the physical layer do? See, it's important to understand it from this point of view, without equations, without protocols and all this stuff. It's just really, really simple language. I don't want technical jargon. As simple language as possible. The reason is if you use as simple language as possible, it generalizes. It never goes out of style. So what's the job? So can you finish the sentence? What's the job of the physical layer? Yeah? Yeah, go ahead.
Maybe signals.
Signals, okay. So, thank you for being brave. So anyone else? What's the job of the physical layer? You want to try? Oh yeah, go ahead. You want to try?
Transport bits.
To transport bits, okay. This gentleman here? Yeah, what's your name? Yeah. Ricardo, yeah, tell me. Just a guess?
Bits as electricity, like battery,
Okay.
certain voltage level.
Okay. I think you're all like there. So anyone else? Somebody in the back row there? This gentleman with the green shirt? Hi. Are you wearing a green shirt? Blue shirt. See, you're so far. It must be the refraction or something. Tell me, what's the job of the physical layer? Huh? Signals. Okay. So, it seems to me like you maybe haven't done this before, but you're going to do it today. Okay. Today we're going to talk about a single sentence for every layer. Okay. So the job of the physical layer is to learn how to use the communication medium. Okay? So if I'm using electromagnetic radiation, then the job of the physical layer is to figure out how to embed information in electromagnetic signals. If I'm in a submarine underwater and I'm using acoustic communications, the job of the physical layer is to figure out how to use vibration of water molecules to communicate information. If I have an optical fiber, the job of the physical layer is to figure out how to use light to communicate information. So does that make sense? It's the most general way of looking at it. All of you are right, but it's very specific to a specific communication system. But this is not specific to any communication system. Right? So the job of the physical layer is to learn how to use the communication medium. Right? So what the physical layer does is it creates a link. So if I have a source, a sender, and a receiver, and there's a communication medium between them, the physical layer creates a link. So that's another way to say it. It creates a link that uses the underlying physical medium, creates a link over which you can send information. You said bits, but it need not be bits. But let's say bits, that's also fine. But it creates a link that uses the underlying communication physical medium to send information. Now, what does the data link layer do? Any ideas? So again, the job of the data link layer is fill in the blank. You guys, any thoughts? The three gentlemen here. Hi. Any ideas? Or any thoughts? What's the job of the? A bit louder.
The data link level
Yeah. What's the job of the data link layer?
handles the data transmission
Okay.
between the nodes.
Yeah. Okay.
So instead of transmitting kind of electrical signal, it converts electrical signals into data bits of 1 and 0.
Okay. Yeah.
The data link layer packs the data so that other person,
Okay.
other party can understand it.
Okay. So I think all of you are there. This is new to you, I know. But trust me, this is how you understand the network protocol. Okay? So, I mean, you're all there. But try to take a step back. What's the real job of the network, of the data link layer? It includes this, but there's a one sentence that will capture everything. Who's speaking? Oh, sorry. No, you guys are like ventriloquists. I don't know who's speaking. Transmit bits. Okay, yeah, that's all there. It's good. Thank you for responding. Yeah. Interprets the signals. It has to do that in this job. Yes, it's not his main job. So yeah. Oh yeah. Go ahead. Huh? From router to router. You want to say something? Okay. Congestion control. No, that's not data link. Yeah. Flow control. It's part of it. Yeah. So again, yeah. You have something to say? Put sequence of bits into frames. Yeah. So I mean, all of you are like like what, okay, I'm not saying that, what I am getting at is here, you all are there. You're like within some radius. Okay, so the job, okay, so I told you the physical layer creates a link. The job of the data link layer is to create a reliable link. Is to make that link reliable. And all the things that all of you mentioned are mechanisms for doing that. But once you realize that actually, like framing is not the function of the link layer, it's a mechanism used to do something. That means there must be multiple ways of doing it. You're not tied to framing only. Right? So the job of the link layer is to create a reliable, or to make the link, so the physical layer creates the link. Right? It uses the underlying medium. The data link layer doesn't care about the medium, because so this is the abstraction, right? The data link layer doesn't care if the link is optical, if it's wireless, or if it's underwater acoustic. The physical layer took care of that. That's the divide and conquer. Physical layer took care of the medium and told the data link layer, here's a link. The link layer says, okay, you've given me a link. I'm going to build mechanisms to make that link reliable. Right? So retransmissions, all of the things, framing, retransmissions, and all that stuff is to create a reliable link. Checksum, the CRC, is all part of creating a reliable link. So do you see the level at which we are describing? Okay, and once you understand that, so you should articulate in your own words exactly, almost like single sentence. If you need 2 sentences, fine. It doesn't matter. It's not about number of sentences, but in a compact way, describe the function. Okay, let's move on quickly. So what's the network layer? What's the job of the network layer? See if you can use my language now. Right? Physical layer creates a link that uses the underlying physical medium. The data link layer makes that link reliable. What does a network layer do? A bit louder? Connects different networks. Yeah, I think you're kind of there. So now you have, remember we have all these nodes, right? And there's all these links between all pairs of nodes that can talk to each other. Whoever can talk to each other, there's a link. The physical layer has made a link. The data link layer has made that link reliable. So remember, what was the communication problem? That's why you always have to go back to the communication problem. I want to communicate, send information between a sender and an intended destination. So the networks layer's job is to find a set of reliable links that connect the sender to the destination. That's routing. And that's another way of saying routing, but I don't want to use technical jargon, right? So I want to find a set of reliable links. Now notice, the network layer doesn't have to worry about reliability. Who took care of reliability? The data link layer. The network layer says, I'm going to find you a path from sender to destination. Finding a path means finding a set of reliable links that connect sender to destination. So we already had some reliability at the data link layer. But remember, the data link layer was reliability between one node to the next node. So can anyone tell me what the job of the transport layer is? Yes, you're going to tell me flow control, congestion control. By the way, congestion control was transport layer, not network layer. But again, that's like too detailed. Take a step back. I'll give you a hint, it's about reliability. So the transport layer is about reliability. So does anyone know what's the job of the transport layer? And don't say TCP, because that's not the job of the transport layer. That's a protocol that sits at the transport layer. What does TCP give you? That's the job of the transport layer. to make sure the data that's transmitted is good. Okay.
No, I think the transmission is good.
That the transmission is good. Okay. Yeah, I mean, it's there. So the job of the transport layer is to make sure that the data gets to the destination. We call it end-to-end reliability. The link layer gives you hop-by-hop reliability. You get it, right? Between one node and the next node. The transport layer is between the sender and the destination. Right? So it would turn out a lot of the ideas that you studied at link layer, like you talked about sliding window, right? Did you or not? You talked about retransmissions, right? You talked about stop and wait. And you talk about like all different ARQ schemes. All those apply at transport layer as well. Why? Because it's the same problem, but the scope is different. Instead of one node to the next, it's between the sender and destination. And that is the job of the transport layer. So think about it. We've already almost solved the big problem, right? We started off with information at the sender. The physical layer figured out how to use the medium, create a bunch of links. The data link layer created a bunch of reliable links. Network layer found a path. And transport layer made sure that the destination actually got the message from the sender. I mean, for all purposes, we've solved the communication problem. Okay, and this right here is the TCP/IP stack. Right? If you go like above the stack is more like becomes things like user interface and application. Okay, it's important, but it's more like dealing with the user as opposed to the core communication problem. Okay, so the application layer is the user interface where data is generated. For the moment, I'm going to skip presentation and session. They have to do with data formatting to make sure that the sender and receiver can understand each other. Okay, and often presentation, session, and application are merged into one. Okay, so on the internet, for example, the TCP/IP stack is application, transport, network, link, physical. Physical is there. It goes down to the link. Okay, so all right. So I want you to take some time on your own to go and articulate to in your own words what's the function of every layer at a slightly higher level, right? Not words like framing and TCP. Okay? Any questions? Okay. So I think you've already talked. Yeah. So this is the TCP/IP stack. I'll just say one more thing that's kind of important called encapsulation. Right? Did you discuss this? Right. So as data moves, so data starts at the top at the application layer, at the sender, and it moves down the stack. And as it goes down the stack, each layer appends some information in a header, or in the case of the link layer, header and a footer. And the information in the header and footer allows the layer to do its job. So at the receiver, the physical layer will first receive it, and then the data will go up the stack. And each layer will strip off the header and use the information in the header to do its job, to carry out its function, which we just got through explaining what the function of the different layers were. Okay, so this is a very important idea, encapsulation. Okay? And every layer has some information that it adds into the headers. Okay, my last thing, okay, so now there's a kind of a design paradigm called cross-layer design. Now, layer design has a lot of benefits, right? Because each of the layers is kind of isolated from the other layers, there's no dependencies. So for example, if I'm at layer 2 and I want to design a new layer 2 algorithm, I can. I can just innovate there, and then as long as I provide the same service to the layer above and below, everything's okay. The inside, the internals of the layers don't matter. So you can innovate, you can do code reuse. I can take a network layer protocol from this system and use it here, as long as I match the interface. Okay? So that's the benefit of layering. Okay, there's a lot of benefits. But we saw that, remember with the sending a letter, there was a price to layering. What was the price in that example? Time, right? One solution was much longer than the other. So there's a price to layering. And the way to this design paradigm shift of cross-layer design is meant to sort of recover that performance loss. So that price leads to a performance loss, and you want to recover it. And so cross-layer design is the idea of violating the layered solution, but you violate it in a very structured way. Okay, and so that's all I'm saying here. I'm going to say not much beyond these pictures. You can Google cross-layer design. But the idea, like one example is here, where so this is one example where you punch holes through the layers. So in case you didn't figure it out, the network protocol stack is software, right? Running on your computer, and each layer is just a function call, right? So when I say punch a hole, I just mean that this layer can use information from this layer. Whereas you're not allowed to in the strict layered paradigm. You can only talk to the layer above and below. But there's no reason why you can't design your function to use more information, right? And if you do it in a controlled way, you still get some of the benefits of layering, but you can recover some of the performance losses. That's that. You can also have shared memory. So this is an example of where you have a shared memory, and each of the layers can access that shared memory, all right? Or you can have, you can do it at design time and so on. So the takeaway message is that cross-layer design allows you to increase performance, because layering, you pay a price. There's a bunch of benefits, but there's a performance loss. You want to recover some of that performance loss, but still maintain some of the benefits of layering. So cross-layer design is trading those two off. Okay? And if you want, there's an article here which I want you to read. It's the first article. It's called Cross-Layer Design, A Survey and the Road Ahead. It's kind of old. It's an old paper now, but it's pretty generic in that we try to taxonomize. So this is with my student Vineet. So Vineet and I wrote a paper. We tried to taxonomize the approaches to cross-layer design. What are all the general approaches to cross-layer design? And then as of 2005, we classified all those approaches into our taxonomy. But since then, obviously, there's been a lot more research. Okay? So, but that article, I want you to read. It's a pretty easy article. Right? It shouldn't, it's not technically very, very, very difficult. So please read it. The other articles are not required. So the required reading is really just the first one. The others are things if you're interested in, okay? So they talk about the design of the internet and so on. Okay, so some of the thought processes that went into designing the internet and internet protocols. Okay, but I've uploaded all of these to our to Luminous files under the folder called supplementary reading. Also, the information here is chapter 1 and section 1.5 of Kuros and Ross. And there's another book I'll recommend called Data Networks by Britsekas and Gallagher. And section 1.3 on there talks about layering. So again, it's to give you slightly different views. Okay? So with that, I think I'm going to stop talking about layering. In this set of slides on layering, I also give you the 7 more slides, which are taken from Cisco systems. Okay? They are Cisco's sort of understanding of the functions of the different layers. Okay, and Cisco is sort of one of the major networking companies, so what they say about networking and layering has merit. Okay, so you can read that. Okay, I'm not going to talk about it in class, but it's there for you to read. Okay, so with that, I want to stop talking about this and ask if there are any questions. Okay, there's two more things that I want to do. So I'm going to try an experiment. Okay, you guys have either a phone or something? Does everyone have a communication device? We're going to try, and I don't know if you've used this in any of your classes, but Poll Everywhere. Have you guys used it? So it should be, okay, good. So I don't have to explain it to you. But I'm going to try, we'll try doing something with Poll Everywhere. So, okay, so I created a bunch of, so let's see here. So let's try this. Okay, so, oh yeah, so the first thing is, so you go to pollev.com/Motani. Now, actually, if you want to, you can also log in. So now you can log into Poll Everywhere using your NUS ID. Did you know that? So if you want to, you can. For this poll, you don't have to. I made everything open. But maybe in future, I want to make the, so you can try this later. For now, you don't have to. Just go to poll. Oh, I didn't intend to show this. Hang on. I forgot to turn that off. Sorry, I don't want to. Okay. So don't worry. Just go to pollev.com/Motani, and you should be able to at least start with the first question. So please do it now, because the way that Poll EV works is I can't show you the next question until one question is done. Okay? I can only have one active poll. Okay, so maybe quickly do it. I'll give everybody about a minute or so. I think there's a timer here too. Let me see. Can I actually put a timer? Can I start it? Okay. So we'll just give everybody a minute. Just type in your student number. In the future, as I said, I'll ask you to log on, but I didn't want to. I want to. So what you can do before next class is just make sure that you can log on to Poll Everywhere using your NUS Net ID. Okay. I didn't want to deal with difficulties in logging on here because it would take too much time. So this poll is open. So has everyone answered this question? If you haven't, can you let me know? Okay. Can I pause this timer? Yeah, I can pause it. Okay. So everyone done it now? It's just type in just go to pollev.com/Motani. You can do it on a phone. It actually works pretty well on a phone as well. They're using a design that scales to the device that you're using. Okay, so everyone done? I'm just curious if I really let this thing go, will it just move on to the next one, or will it just tell me? Let's see what it tells us. Oh, it just does that. Okay. So the next one is this here. So if you're at the page, it should automatically go forward to the next question, right? All right. So I think if you want to, you're allowed to change your mind. I set it up. You can only give one answer, but you can change. You can cancel your response and change your mind. Okay. What was the question? Yeah. So between the network and application is the transport layer. So I think this is good. So what I'm going to do is, try to respond to this within a minute. Okay. Some of these are easy questions. It's just to make sure we're all on the same page. And also, you can all use the tool. Okay, don't worry. The questions will get more interesting. But I want to make sure we can all use the tool first. Okay. So the layer that sits between the link and the network. So what is the layer that sits between the link and the network? If it's none of the choices, then which one is it? What's the answer? Okay, yeah. There's in the OSI stack, there's no layer between the data link and the network. Okay? Because they're adjacent, right? The network layer is layer 3, the link layer is layer 2. Okay. It's okay, so don't worry about if you got it wrong or right. This is not a, but I hope, so I'll ask you some questions at the end of it. I want to get your feedback on how useful this kind of feedback is. Okay? So let's just continue. I have about 10 questions. So we've done 2. So both TCP and UDP belong to which layer of the OSI model? Yeah, so I think you guys are good at this. So some easy questions. Yes, so TCP, which stands for Transmission Control Protocol, and UDP is User Datagram Protocol, are 2 protocols that sit at the transport layer. And again, what's the main job of transport layer? Yeah, say it. So, I heard it. End. Can you finish my sentence? Yes, end-to-end reliability. And the end-to-end means sender to destination. Okay, how about this one? So it looks like the crowd is a little bit split between these 2, right? So, but the majority of you say it's this one. So, someone want to explain why it's not this one? A bit louder? Yeah, because we'll see later that IP address is 32 bits long, and each of those decimals are 8 bits. So you have 4 8-bit decimals. If you have an 8-bit unsigned integer, the maximum value is, it goes from 0 to 255. There's 256 values, 2 to the 8th, right? And 265 is greater than 255. Yes, so that's not a valid IP address. So the crowd is correct on this one. This is the valid IP address here. And in fact, this is NUS domain. 137.132 is NUS domain. NUS is public IP domain. It's not the private IP. The intranet is 172 dot or 10 dot. Yeah, so again, the crowd says switch. I see in all of the above. So a bunch of you said, about a quarter of you said all of the above. So this can be a little bit confusing, but yes, a switch is a layer 2 device. But I told you it's confusing because there exist layer 3 switches. Right? You can actually go on the market and buy a layer 3 switch. Right? But it turns out a layer 3 switch is a switch and a router. A router is a layer 3 device. A switch is a layer 2 device. Okay? And so it's definitely not all of the above. Okay, so it's pretty much well accepted that a router, right, connects 2 subnets. Okay, we'll see that later. So it's going to be definitely not, right? And anytime you connect 2 subnets, you need to deal with network layer information, right? The network layer header information is going to be needed. So we call a router a layer 3 device. There's kind of no, let's say, ambiguity about that. The only ambiguity is switch. Okay, but switch is a layer 2 device. A layer 3 switch is a combination of a switch and a router, maybe for efficiency purposes. Right? Like for example, your your Wi-Fi router in your house does layer 2 tasks as well as layer 3 tasks. Okay? So yeah, and I'm guessing this this line is going to get blurred even more, right? As people start to combine functionality into single devices. But no one said firewall. Oh yeah, let's go here. Okay, so now which of these networks? So before I asked about link layer, now network layer. So switch is a layer 2 device. Layer 2 is link layer. Network is layer 3. Okay, so all of the above is not correct, right? Because that includes switch. Okay, so if you hit all of the above, it was by mistake maybe. Remember, anyway, this is just getting used to the tools. You can actually change your choice. If you look on the page you're at, you should see a little trash can. Is there? What do you guys see? Do you see something to?
No, there is no clear.
It should be there. I saw it. Let me see.
Usually there's clear last response.
Yeah, how come it's not there?
Yeah.
I don't know. It's not there. He's right. No, when I was testing it, wow.
There will be a clear.
Yeah, there's a clear, right? I don't know why it's not there. I'm bugged out now. Okay, so don't worry about it. On this one, I don't care. But if you put all of the above, just think about, do you want to include switch or not? Right? You probably don't want to include switch. Switch is a layer 2 device. Okay, the only, let's say choice would be between router and firewall. Now you know router is a layer 3 device. So the question is firewall. So in this case I would say, well, I don't have a choice that says router and firewall. Right? So what would be the best choice? Right? Let's say that you somehow were a bit unsure if firewall was a layer 3 device, was a network layer device. You should be sure that router is, right? So what, if you had to pick one choice, which one would it be? Yeah, you should choose router, even if you're unsure about firewall. Now, it turns out there is a little bit of ambiguity. Typically, a firewall is used for port filtering, right? So block certain ports, which makes it a transport layer device. But you can use firewalls to also block IP addresses, which makes it a layer 3 device. Right? But the typical use case for a firewall is not to do that, is to filter by port. Right? Which is why you can't run you can't run BitTorrent on campus. Right? Even though there are perfectly valid uses of it. Right? But you can't. Right? Because that port is blocked. Okay? So here, yeah, let's say the most reasonable answer here is router. So this says, which of the following manages the conversion between IP address and host name? So the question is, when you type google.com, right, you don't actually generate packets for google.com. You generate packets for an identifier that's in the form of a numeric, the IP address. So I'm asking, what does the mapping between google.com and the IP address of the server that's handling google.com? That's the question. Yeah. I think some of you are just playing, right? It's okay, but I just want to make sure that, yeah, Yeah, but anyway, at this point, I guess I don't expect you to know, but it's DNS, right? DNS is domain name system, and it's the protocol that's used for mapping between friendly names and IP addresses. Okay, so obviously somebody's playing around. Yeah, I will get the clear my selection working. I don't know what I did. It must be a setting. Okay, so yes, layer 2 frames contain MAC addresses. Okay, so I noticed that some of you wrote IP addresses. I think some of this might not be playing around, but I think it's just clarifying now. Okay, so we're going to see that in the stack there's going to be 3 places where there are addresses. Okay, one is in layer 2, which contains MAC addresses. The next place is in layer 3. Okay, so what are the destination source fields in layer 3? So layer 3 is a network layer. So that should give you a hint. Right? The way we identify nodes on the network is by their IP address. Okay, so in this case, the addressing information at the network layer at layer 3 is the IP address. I'm going to have to find a way to get even. Okay. And so I said there were 3 places, right? So layer 4 also contains source and destination fields. So does anyone know in Poll Everywhere, can you summarize these? Like at the end of the day, can we summarize this? The distributions? Like has any lecturer ever said, okay, here are my questions, and I told you here are the answers that you gave? No? Okay, I think you can. I'll figure it out. Okay. So this is good. This is going faster than I thought. We seem to have stabilized, but I'm not sure. Okay. All right, I'm going to move on, okay, in 10 seconds. 10 on 8. 7, 6, 5, 4, 3, 2, 1. Okay. One more. Come on. Because there were 83 before. I don't want to be unfair to the 83rd person. Somebody's falling asleep. Come. Put it in. Oh, that's it. It was done. Okay. Okay, so that was good, actually. That was fun. So did you find that useful? Like, as in, I mean, the questions were easy, but is the interface useful? Like, do you like this? Okay, can we do this? Okay, then I mean, if we agree, I'm going to do this. Okay, so for all our activities, we'll do something like this, unless it has to do with something that I want you to write. In which case, I'll bring in a handout. Okay. Okay, so I think we're almost done. So what we're going to do next time is we'll talk about what I call internetworking, which is still sort of intro stuff, but internetworking, and we'll also do some live, let's say network analysis. Okay, network or just try to run some commands and see what networking is all about. But I want you to also think about something else. Okay, it's a question that I'm not going to answer today, but I want you to start thinking about it, and I want to set the stage for you. So you probably already figured out by now, layer 2 has MAC addresses, source and destination, right? I mean, so a network interface card has a unique MAC address. So every network interface card has a unique MAC address. Okay? And layer 3 contains IP addresses. And in a connected network, so I'm very precise with my language, okay? I'm not just speaking, that's why I'm saying slowly. In a connected network, every network interface has a unique IP address. Okay? So if I have a connected network, meaning a network where, so a connected network is like a connected graph, right? Your nodes are the vertices of your graph, and the edges between the nodes are the connections between the vertices, okay? They're the links. So a connected graph or a connected network is a network or graph in which there exists a path from any node in the graph to any other node in the graph. Okay, so there's no disconnected node. Okay? That's a connected network. So, and in a connected network, every node has a unique MAC address and a unique IP address. Okay, meaning specifically on the internet. I'm talking about internet protocols. So that's why this question now should make sense. Why do we have both MAC and IP addresses on the internet? So to make you think why this question actually makes sense, think about where you live. How many addresses does your house have? Yeah, like you live somewhere, right? Huh?
Changes all the time.
You move so much?
Yeah.
But when so let's say you haven't moved. Like tonight you're gonna go somewhere, right? You're gonna go home, right?
Yeah.
How many addresses does that home have? One. Right? I mean, think about it. You have one address. Your home doesn't have two addresses. How many addresses does the post office need to send you a package? One. Okay, so that's why this question is interesting. Why do we have both MAC and IP addresses on the internet? So I told you we're going to ask why, right? We're not going to just see. You see, the traditional way that people learn is they just have the fact. Oh, on the internet we have MAC and IP addresses. Stop, and you move on. But I told you I want to do things differently. So we're going to ask, why is that the case? Because actually, when I first started learning about networking, this bugged me, right? Because I thought, well, you have one address. Okay, so the way to think about it is in a connected network, how many addresses do you need to make the network work properly? Ricardo? Okay, do you all agree with Ricardo? Who agrees with Ricardo that one address is all you need? If you agree with Ricardo, raise your hand. If you don't raise your hand, it means you disagree with Ricardo. And I'm going to ask you why you disagree with Ricardo. So, the current answer is you need one unique address in a connected network to make the network work. What do we mean by work? It means I can send packets from one node to another. Right? Like, clearly 0 is no good, right? If you don't have an address, can the post office send you a package? No. In the same way, YouTube cannot send you a video if you don't have an address. Right? Now, if you have more than one address, yeah, it looks okay, as long as the addresses are unique. Suppose you don't have unique addresses. Suppose that you and I have the same address, the same home address, but we're two different houses. Can the post office send us a package? They wouldn't know where to bring it. What? That would be nice. So like you order a new phone and I get one, right? We both get it. I like this. I like the way you think, right? So the current response by one of your classmates is that in a connected network, you need that every node needs one unique address. And I want you to make a decision, do you agree with that or not? So if you, I'm happy with saying if you don't agree, raise your hand. But then no one, okay, tell me, okay, good, somebody raise their hand.
If we combine into the analogy of the post
Yeah.
At the post office, when they put the letters into the truck,
Yeah.
they also must specify which truck they want. So we need a real source and a real destination, but in the way between the layers, we also need addresses to know where these things will be sent to different blocks.
Yeah, but you can give the post office an address as well, right? The post office, I mean, as I said, the post truck has address. It's okay. I agree, but that's the address of the post truck, of the postal truck. That's fine. There's no problem with that, right? I mean, nodes have one, and intermediate nodes have one too. But you can't have two trucks having the same address.
Then where would we write them?
Hmm?
Where would we write the addresses?
But you see, like the trucks play the role of the core routers on the internet. Do you know which core router you're using? You don't need to address the core router. You need to only address your final destination. The protocol takes care of it. The network layer takes care of it. Yeah. So this is a question for you. So the answer is you need one. In a connected network, every node needs one unique address. So these questions should make you think. When I first learned about networking, this bugged the hell out of me. Why are there two? And that's what I want you to think about. I want you to figure out or come up with an answer to why do we have two unique addressing mechanisms on the internet when you need only one. Okay? What I'll do is on Wednesday, I'm not going to give you the answer on Wednesday. On Wednesday, we'll do some other stuff, but we'll maybe try to get more ideas on how to answer this, and I'll answer this next Monday. Okay? But come in ready to think. Okay? Thanks. If you have any questions, I'll be around.